All right, so now we move on to lesson 3 of equations, and this is solving equations with simple fractions. So in lesson 1 and 2, we've done a lot of work with when coefficients are plus minus 1, when coefficients are some integer value like 3, 4, negative 5, things like that. But now, what if we introduce things that involve fractional terms or simple fractions? Well, let's consider the following here. If I was given the equation 3 over 5x plus 2 equals 1 over 4, well, I know that in order to create this statement here, or in order to work with this statement, I have to realize that I need an LCM in order to make a common denominator. So here, I would recognize that in order to get rid of the 5 and the 4, I need to create an LCM such that those terms disappear, and the LCM is actually just the product of those two numbers. So from number sense, we would have actually seen this many times before where we wanted the lowest common multiple or our LCM. How did we figure that out between two numbers or three numbers? You have the skills for that. So we know in this equation here, we're gonna have to multiply both sides by 20 because that is our LCM or lowest common multiple. When we take the original equation, which is given here, and then we multiply both sides by this 20, well, what we're doing is we're actually taking the coefficient values of each of these and multiplying them into the numbers. So when I go 20 times 3 over 5, well, 20 times 3 over 5 would give me 20 times 3 over 5. And I know if there's a two-term polynomial or something that's two terms, we know this is a binomial and we have to expand the 20 into both terms. When you expand 20 into both terms, you are given the following. And then when you expand 20 onto the other side, we have 20 times 1 over 4. So now if we do a little bit of simplification here, 20 times 3 is 60, and 60 divided by 5 in this case gives me 12. 20 times 2 gives me an answer of 40. 20 times 1 over 4, that's like 20 over 4, and that's equal to 5. Now, we recognize this statement from our previous lesson. We're dealing with integer coefficients. Once we've dealt with our fractional terms, it now becomes something recognizable to what we've done in the previous classes. We want to isolate this x term by subtracting or doing the opposite operation to both sides here. We subtract away a 40, which eliminates it on the left. And now 5 minus 40 on the opposite side gives me negative 35. Finally, my last step here is to say, if I have things being multiplied to an x, I need to divide them away in order to get rid of them from that side, canceling them from the left, giving me x is equal to negative 35 over 12. Now, the nice thing is that if we look at this statement, it actually doesn't reduce any further. You could type this here in your calculator, but our final statement should just be the following. There's no more terms that are common between these numbers, so we can't reduce this anymore. All right, so now we just really want to draw attention before we look at a second example there. What if we have three numbers being multiplied together? Well, we would say 2 times 3 times 4 would give us 24, because 2 times 3 would give us 6, and 6 times 4 would give us 24. Now, this is the right solution, but however, you may be tempted to do from our polynomials unit, if you see 2, you might think, oh, well, I should just distribute it to these two terms. And then, okay, well, 2 times 3, and then we get 2 times 4, and that gives me 6 times 8, which is 48. No, we do not want to distribute in this case. What is missing that allows us to, or says that we shouldn't distribute here? The piece that's missing that says do not distribute is there's no brackets as the following. And maybe I'll do that in a different color here just to make it a little more obvious here. There is no brackets right here. If there's no brackets surrounding these terms with some coefficient out front like 2, then we know it's not correct to do the distribution, and rather we're just simply multiplying the three numbers together. Now, let's go over to an example 2 here. We're given this statement, 1/5 x plus 1/3 is equal to 2 over 5 times x plus 4. Well, in order to deal with this here, we need to realize that an LCM here, if I look at all my denominator terms, 5, 3, and 5, what is the first number that both of these numbers, 5 and 3, multiply to? They multiply to 15 as the first number that's common between both of these two as a multiple. So we consider this 15 to be our LCM. If you wanted to write this as a note here, what is this 15? It's an LCM between 5, and 3. Okay, so we multiply 15 to both sides here. We know on the other side, we're going to take, or on my left-hand side, first of all, we have two terms here, and they both need to be multiplied by the 15. 15 times 1/5, 15 times 1/3. I then go to the other side and say, I have this coefficient here. I'm going to multiply my LCM with that coefficient and then distribute it to both terms here. So piece by piece, 15 over 5 becomes our first term. We then say 15 times a 1/3 is 15 over 3. We then have 15 times 2 over 5 as our coefficient term here. And now we need to simplify this. 15 over 5 reduces to 3x, because 15 divided by 5 is 3. 15 divided by 3 would give me 5 here. Now, 15 times 2 is 30. 30 divided by 5 is equal to 6. So now, once we have it in this reduced form, yet again, we're back to lesson 2. We want to take this 6 and expand it into both of the terms in this binomial. When we expand it, we'll get 6x plus 24. And now we realize we want to make this a positive x, and we want to make sure that all the numbers go to the other side. Well, where the x is less, 3 is less than 6. So why don't I move the 3 to the left-hand side, or to the right-hand side, I should say, by subtraction, because we know this is addition. So if this is an added term here, we need to subtract away 3x from both sides, giving me 3x on the right-hand side. Now, we have the two terms 5 and 24. In order to take a positive 24 from the right-hand side and move it over, I have to do subtraction, which will allow me to eliminate it from my right-hand side. And then 5 minus 24 is equal to negative 19. Finally, I have a number multiplied to the x. I have to divide by that specific number to both sides, therefore giving me x is equal to negative 19 over 3. Now, here's what I want you to recognize. Remember from lesson 2, we had talked about, does the order matter across the equal sign of the x and the solution? No. As long as the terms are kept consistent, I could say x is equal to negative 19 over 3. And like I said in class, this is something that is more common for sure. When we see the x come first, or whatever variable come first, this is more common for any given answer within a multiple choice or a diploma or whatever it may be. So just get in the habit of realizing that this is congruent to this, or equivalent form. Okay, let's flip over the page here. Steps to solve equations with fractional coefficients. Well, just like we did with integer values, we want to expand the brackets. We want to multiply every term by the LCM. So this is our new step here. Then combine like terms, isolate the variable, and then finally divide every term by the coefficient attached to the variable. And if we need to check our answer, it will specifically ask us. So if it says check or verify, we need to take our solution and plug it into the original. Now, let's look at the following here. Solve each equation. Okay, if I look at this, I need to recognize that my LCM, or my lowest common multiple, comes from whatever the denominator is in terms of an LCM. So my LCM for this problem here, LCM is equal to 5, because there's only one term here. So if I know my LCM is 5, I'm going to take both sides and multiply them by 5. Multiply by 5, multiply by 5. The 5 is going to distribute into the brackets on both sides. So I'm going to be given 5 times 2m over 5 plus 5 times 4 is equal to 4m times 5 minus 20. Now, I can reduce these two terms here. 5 divided by 5 is just 1. And now I have 2m plus 5 times 4, which is 20, is equal to 4m times 5, which is 20m, minus 20. All right, and now I need to isolate for my m term so that I can get m alone. What I'm going to do here is I'm going to take away 2m from both sides. This is going to give me 20 is equal to 18m minus 20 Now, I have to add 20 to both sides here because it's being subtracted, so I'm going to add 20 to both sides. Therefore, my solution at the end here, I should get 40, and I'll do it off the side here. We get 40 is equal to 18m. And finally, to get our solution for m, we need to divide by 18 on both sides here. So therefore, m is equal to 40 over 18. Now, I could divide these or reduce them. So if I wanted to reduce this statement here, I could say that m is equal to, well, if I divide both by 2, I would get 20 over 9. And in this case, I actually can't reduce it anymore here because there is no more terms I can reduce from here. So my m in terms of a reduced value is 20 over 9. Okay, let's go to b here. I would look at this and I would look at my denominators and say, okay, between 4 and 2, my LCM, or the first number that both 2 and 4 reach when they're multiplied, or the first number they can both multiply to, is actually 4. So you're going to take both sides of this equation and we're going to multiply it by 4 on each side. If I distribute this, this is going to be 4 times 5x over 4 plus 4 times 8, which is 32, is equal to 4 times x over 2 minus 5 times 4, which is negative 20. Now, we should realize that the 4 divided by a 4 will give us 1, and I have 5x plus 32 is equal to 4 divided by 2 reduces down to simply 2, and so I have 2x minus 20. What I'm going to do here is I'm going to take the lesser of the x's and move it to the other side, keeping my x term positive as 3x plus 32 is equal to negative 20. And then finally, I need to take this negative 32, subtract it from both sides, giving me 3x is equal to negative 54. Okay, let's take this solution and see if we can simplify it. I have 3x is equal to negative 54. Let's divide both sides by the common 3, or the multiple of 3 on that x. This is going to isolate x by canceling the 3's, and therefore I have x is equal to negative 54 divided by 3. And that will reduce down to negative 18. So x is equal to negative 18. Okay, let's move on to c here. So c, I have 7 over 3 minus, or 7x over 3 minus 6 is equal to negative 2x over 3 minus 9. The LCM here, or lowest common multiple, is equal to 3. So I need to multiply both sides by 3. Multiply both sides by 3. When I distribute this, I'm distributing 3 into each of the terms in the bracket. I have 3 times 7x over 3 minus 3 times 6, which is negative 18, is equal to negative 3, or specifically negative 2, because if we have this negative here, we know it will apply to the 3. So I could write this as negative 2 times 3 over 3 minus, in this case, negative 9 times 3, which is negative 27. Okay, now I want to reduce the terms I can. I realize on both my left and right, I have a 3 divided by a 3, which is 1. A 3 divided by 3, which is 1. And I realized I'm missing an x term here, so I'll make sure to go and include that. You should have your x term here. So this becomes 7x minus 18 is equal to negative 2x minus 27. Now, the x's are less on the right-hand side in comparison to the left, so I'm going to take those negative 2x's and add them to each side. This is going to cancel the x's on the right-hand side, and I'm given 9x minus 18 is equal to negative 27. If I add 18 to both sides to eliminate the 18 from the left, it's going to eliminate the 18 from the left, and I'm given 9x is equal to, and then the difference here should be negative 9. Finally, I need to take my 9 that's being multiplied to the x and divide it off using the opposite operation. Therefore, we get x is equal to negative 1. All right, so now we move on to question D here. And question D is very similar to one that we would have solved in lesson 2. The only difference now is that we have a fractional component to it, and it says solve for A. So we have two variables and we want to isolate it for in terms of A. How do we get an LCM when we have three different numbers? Well, the way we did it in number sense is to say, if I want the LCM, it's actually the product or the multiplication of these three terms. 2 times 5 times 3. So therefore, what is my LCM? Well, 2 times 5 is 10, times 3 is equal to 30. So if you have three different terms, an easy way to get your LCM that we know from our number sense unit or unit 1 is just to multiply those terms together. So now I'm going to take that 30 and multiply it to both sides of the equation. So we have 30 and 30. When I distribute 30, I'm going to get 30 times 5a all over 2 minus 30 times negative 7. 30 times negative 7 is equal to negative 210b is equal to 30 times a negative 2 over 5, or negative 2 times 30b over 5 plus 2a times 30 over 3. That's 2 times 30a over 3. Okay, now we want to reduce the terms if we can. So if I divide these, 30 divided by a 2 is 15. If I take the one on the right-hand side here, I can say 30 divided by a 5 is equal to 6. And 30 divided by a 3 is 10. So my new line will look like 15 times 5a minus 210b is equal to negative 2 times 6, which is negative 12b, plus 2 times 10a, which is 20a. So now, if I go to my next line, I'm going to go 15 times 5 with an a on it. This is 75a minus 210b is equal to, and now I have negative 12b plus 20a. Remember what they asked for in this problem though. They wanted us to solve for a, or isolate a. So what I'm going to do is I'm going to add the more negative of the two a's to the other side. I have a more negative value here than on the left-hand side. So I'm going to take negative 12b and add it, or I guess I should say the opposite. We're looking to move our a across. We're going to subtract away 20a and subtract away 20a here. 75a minus 20 is equal to 55a minus 210b is equal to negative 12b. And now I need to take this negative 210b and add it to the other side. Negative 210b plus 210b. I have 55a is equal to 12, or negative 12, minus the 210, or plus the 210 I should say, is equal to positive 198b. And now, in order to get a isolated on its own, what I'm going to have to do is divide by the 55 on the a. Divide by 55, divide by 55. So, therefore, a is equal to 198b over 55. If I take 198 and I divide it by 55, it won't reduce evenly in this case. So we could actually just state it as 198b over 55. And there is our final solution here. So if we want an LCM with three different terms, just remember an easy way to get that LCM is to multiply all three numbers together. That becomes your LCM. Multiply it to both sides there. All right, now for the U trisection here. The U trisection, we're going to take this and we're going to figure out what the LCM is first. We're actually only given one number, so this makes it really easy for us. The LCM is equal to 5. If the LCM is equal to 5, we're going to take that number and multiply it to both sides. 5 times 5. My line will become 5 times 2x over 5 minus 5 times a negative 3 is negative 15. This is equal to 5 times a negative 8x over 5 is 5 times 8x over 5. And then negative 2 times 5 is negative 10. Now, I can cancel out some terms here. The 5 over 5, the 5 over 5, that becomes 1 on both those sides. So therefore, we get 2x minus 15 is equal to negative 8x minus 10. Okay. Now, I want to move the x's from my right-hand side over to the left-hand side. So I'm going to add 8x to both sides, add 8x to both sides. When I do that, I have 10x minus 15 is equal to negative 10. I'm going to add the 15 with the opposite operation to both sides, giving me 10x is equal to positive 5. And then finally, I need to divide by my 10 on my x. If I reduce this, x will be equal to 5 over 10, or 1/2. Okay. Now, if we move on to b here, we want our LCM. That's always our first step here. So our LCM is, we can simply find it by saying LCM is equal to 2 times 3, or the numbers in the denominator multiplied by each other. That means the LCM is equal to 6, and I have to multiply both sides of the equation by 6. So we have a 6 times a negative 3x over 2. That's negative 3 times 6x over 2. 6 times negative 8. 6 times 8, negative 8 should be equal to, in this case, negative 48, which is equal to, now I go negative 5 times 6x over 3 minus 60, or 6 times 10. Let's see if I can reduce some terms here. I have 6 over 2, which reduces down to 3. I have 6 over 3, which reduces down to 2. So negative 3 times 3x is negative 9x minus 48, which is equal to negative 5 times 2, which is negative 10x minus 60. Now, the more negative x exists on the right-hand side, so I'm going to move it over to the left. And to do this, I'm going to have to add 10x to both sides. When I add 10x to both sides, this becomes 1x minus 48 is equal to negative 60. And now, if I add 48 to both sides to undo that operation, this will give me x is equal to negative 60 plus 48 is negative 12. Okay, now, what if we instead we move on to examples that have a variable in the denominator, and looking at the variable in the denominator, we want to get it out of the denominator and onto the numerator in order to solve for the positive coefficient and it to be non-fractional. Well, to do this, we have to isolate the fraction, first of all, with the variable in the denominator. So we're going to move every term away from it. Specifically, if we have an example like this, we want to move the 4 off onto the right-hand side. We want to isolate the term with the x in the denominator, or whatever variable. We want to multiply every term by the variable in the denominator, divide every term by the coefficient on that variable, and then check our answer if required, which it will say to check or verify. So in our first example here, we realize that the x in the denominator is already isolated for. So what we have to do next is we have to multiply both sides by that denominator, which is x. We get, in this case, x over x, which reduces to 1. This is negative 12 is equal to 3x. In order to get x alone, I have to divide by that 3. And so I get negative 4 is equal to x. Or we can say x is equal to negative 4. Both ways are completely fine. If I go into example B here, example B requires me to move the 5 across first because it's attached to the one with the variable in the denominator. So if I move the 5 across, I get 8 over x is equal to 7 minus 5, which is 2. Now, I can multiply both sides here by the x in the denominator, When I do that, it's going to be x over x, which reduces to 1, and I have x, or 8 is equal to 2x. If I divide both sides by the 2 that's attached to the x through multiplication, therefore, my x value is equal to 8 over 2, which is positive 4. Okay, example C here. I have to isolate the term with the x in the denominator. This becomes minus 4, minus 4. This is 24 over a negative x. If I minus 4 from both sides, it's eliminated on the left, and I go 10 minus 4 is equal to 6. I then have to multiply by the negative x to both sides. Okay, so now the negative x's will cancel on the left, and I'm given 24 is equal to, if I multiply 6 to negative x, I get negative 6x because I can move the negative out front. And now I want to divide both sides by the negative 6. 24 divided by a negative 6 gives me x is equal to negative 4. All right, let's move on to example D here. Example D, we need to isolate the term with x in the denominator. I'm going to subtract 12 away, subtract 12 away. This gives me negative 32 over x is equal to negative 20 minus another 12 is negative 32. Now, this negative is actually directly out front, so I could place it, if I really wanted to, in the numerator, in the denominator, out front, whatever I would like. In this case, what I'm going to do for the next line is, because I know it can be placed on either term, maybe we'll place it here and multiply that positive x to both sides. So I get negative 32 is equal to negative 32x. My last step is to divide by the negative 32 attached through multiplication to the x, and therefore I get x is equal to negative 32 over negative 32 means x is a positive 1. Now, just to remind ourselves, if we multiply top and bottom by the same thing, or in the numerator and denominator, it eliminates from both sides here. All right, so now we're on the u-try section. So if we look at the u-try section, well, the nice part is it's already isolated in terms of the x being in the denominator. How do I solve this? I need to multiply both sides by the x or whatever variable is in the denominator. So the x's will cancel here or eliminate down to 1. This is 56 is equal to negative 14x. If I take negative 14 and I divide it to both sides, I get an x value is equal to 56 over 14 is equal to negative 4. Okay, B, I have some term attached to the variable in the denominator, so I need to realize that I need to subtract away the 10 first of all. Subtract away 10, subtract away 10. 15 minus 10 is equal to 5, which is equal to negative 25 over x. To get the x out of the denominator, I have to multiply both sides by that x, eliminating it from the right-hand side. I then have 5x is equal to negative 25, and I can reorder these terms as x times 5 or 5x because multiplication can be done in either order. And now I want to divide both sides by the 5, divide both sides by 5, therefore x is equal to negative 5. Okay, are you up for the challenge? So these ones are a little more difficult. There's a lot more going on with these. Let's see if we can work on these here. So first of all, we want to identify an LCM. Our LCM can be found by multiplying the terms in the denominator. LCM is equal to 2 times 3, which is equal to 6. I'm going to take both sides, and I'm going to multiply them by 6. So if I multiply both sides by 6, I get 6 times 3 over 2 times x plus 4, which is equal to 6 times 5 over 3 times x minus 6. All I've done is brought in that multiple into each of the coefficients here. So 6 got multiplied here, 6 got multiplied here. Now, if I reduce this, I have 6 over 2, which is equal to 3. 6 over 3, which is equal to 2. So 3 times 3 is 9 times x plus 4, which is equal to 2 times 5, which is 10 times x minus 6. If I distribute the outside term to both of the inside terms of this binomial, I get 9x. 9 times 4 is equal to 36, which is equal to 10 times x, or 10x minus 60. Now, I realize that the x's are greater on the right-hand side than they are on the left, so why don't I take the 9 and subtract it from both sides here, which will keep our x term positive. 36 is equal to 1x minus 60. I take my negative 60 and I add it to both sides. And so I have 96 is equal to 1x. Therefore, x is equal to 96. All right, and let's try our last challenge problem here. Number 2, we should realize that our LCM is determined by whatever is in the denominator. In this case, they're the same thing. So our LCM is actually just equal to x. So I need to multiply both sides of the equation by x. Both sides by x. If I multiply both sides by x, I'm given 2x over x plus 8x is equal to negative 5x over x plus 1 times x. I can reduce the x's here to 1 and 1, giving me 2 plus 8x is equal to negative 5 plus x. The x's are greater on the left-hand side than they are on the right, so I'm going to take the x's from the right-hand side and subtract them. And what is this? This is actually subtracting 1x. It eliminates from the right-hand side, giving me 2 plus 7x is equal to negative 5. And now I need to subtract the positive 2 away, subtract the 2 away in order to eliminate it from the left-hand side. And now I have 7x is equal to negative 7. My final step here is to divide by the coefficient 7 and give me an x equal to 7 over negative 7, which is negative 1. All right, this is where you get to go on to your check your understanding. Please practice these. This will require a lot of practice, especially with the LCMs.